Hi, today I want to discuss about the determination of oxidation number. Very simplest method with the some set of rules. Today I want to explain how to determine the oxidation number of any given element in a compound or any ions or anything with the simplest method. The first rule is the sum of the oxidation numbers of all the atoms in the species is equal to its total charge. For example, I am writing this is the H2SO4. This H2SO4 total charge is equal to 0. Now you can take any other compound. For example, KMNO4. This all atoms total charge is equal to 0. For example, if you take the C6H12O6, this all atom oxidation state is equal to 0. Sum of the all atom oxidation state is equal to, or oxidation number is equal to 0. The second rule is for atoms in their elemental form, oxidation number is equal to 0. That is, for example, hydrogen oxidation number is 0. Next, carbon oxidation number 0. Nitrogen oxidation number 0. Like this, maybe taken halogen, that is a F2 oxidation number 0 in elemental form, like boron oxidation number 0. Next, sodium oxidation number 0. Phosphorus oxidation number 0. Sulfur oxidation number S8, that is also 0. Elemental form oxidation number is equal to 0. Third rule, for atoms of group 1, oxidation number is equal to 1. What are the group 1 element? Lithium plus 1, sodium plus 1, potassium plus 1, rubidium plus 1, and cesium plus 1. All these are first group element. These are having what is the oxidation state? Plus 1. For atoms of group 2, oxidation number is plus 2. Example, magnesium plus 2, calcium plus 2, strontium plus 2, barium plus 2, radium plus 2. These are second group cation having plus 2 oxidation number. For atoms of group 13, except boron, remaining elements shows plus 3 oxidation state, sometimes plus 1 oxidation state. Here the mentioned example is EX3, mean this element shows the plus 3 oxidation state. Another one example is EX, meaning this element shows the plus 1 oxidation state. What are the element of 13 group? Boron. Boron generally due to high ionization enthalpy do not show plus 3 oxidation state. It may shows minus oxidation state. That's why you can write minus 3 also. Except to boron, remaining boron, aluminium plus 3, gallium plus 3, indium plus 3, thallium plus 3 is less stable than TL, thallium plus 1, due to inert pair effect. Therefore, thallium shows the plus 1 oxidation state. For atoms of group 14 except carbon and silicon, they shows +4 oxidation state and +2 oxidation state. Carbon and silicon may shows -4 oxidation state because these are non-metals and smaller element. They can accept the electron pair or electron from the other one. Therefore, they can show negative oxidation state. So now here EX4 given meaning what is that? This element will show the +4 oxidation state. EX2 meaning what is that? This one shows the +2 oxidation state. So what are the elements of the 14th group element? Carbon, silicon, germanium, tin and lead. So these element may show the +4 oxidation state, but lead will shows more stable one compared with the +4. +2 is a more stable. Therefore, this is shows the +2 oxidation state. Reason due to inert pair effect. Fourth rule, for hydrogen, +1 oxidation number in combination with the non-metals. What is the meaning of this one? For example, hydrogen may combine with the non-metals like carbon CH4. Then this hydrogen shows the +1 oxidation state. Now NH3 in this hydrogen shows the +1 oxidation state. H2O in this hydrogen shows the +1 oxidation state. Next HF in this hydrogen shows the +1 oxidation state. This is called hydrogen combined with the non-metal shows the +1 oxidation state. The next one, -1 oxidation state in combination with the non-metal, metals. What are that? For example, sodium hydride. This sodium already we know first group element shows the +1 mean compulsory. This is a -1. Similarly, calcium hydride. So calcium second group element shows +2 we know already. Therefore, hydrogen shows -1 oxidation state. So these are called hydrides. Sodium hydride, calcium hydride. When hydrogen with the negative charge, that is called hydride. Hydrogen with the positive charge, that is called proton. Fifth rule, for fluorine, -1 oxidation number in all its compounds. Example, now we can take HF. In this, fluorine is -1 oxidation state. Next, NF3, in this also fluorine -1 oxidation state. OF2, in this also -1 oxidation state. O2F2, in this also -1 oxidation state. Fluorine is there mean in any compound it shows -1 oxidation state. Then fluorine shows only two oxidation state. One is fluorine elemental oxidation state is 0, and in its compound its oxidation state -1. This is two only it shows. That's why in competitive exam one time 2018 NEET question paper this question is asked. Fluorine shows only -1 oxidation state. True or false mean false, because fluorine shows 0 oxidation state also, -1 oxidation state also. If question asked like this, fluorine shows -1 oxidation state in its compound, then that is a true. So carefully we have to know the what is the statement, clearly read and then answer. Sixth rule, for oxygen, -2 unless combined with fluorine. For example, I am taking This is the Na2O. Already we know that sodium is a plus 1 oxidation state, means oxygen, minus 2 oxidation state. Generally in oxide, oxygen shows the minus 2 oxidation state. Similarly, H2O, hydrogen we know plus 1 with the non-metal, then this is called minus 2 oxidation state. Similarly, N2O5, in this also oxygen minus 2 oxidation state. In oxide, it shows the minus 2 oxidation state. Minus 1 in peroxide. Oxygen shows the minus 1 oxidation number in peroxide. Peroxide formula is this one. O2 2 minus. Example, well-known example is the hydrogen peroxide. This can be represented as HOOH. Already we know that hydrogen shows plus 1 oxidation state, plus 1 oxidation state. Here it shows the minus 1 oxidation state. Similarly, sodium peroxide, then in this also this oxygen will shows the minus 1 oxidation state. In peroxide it shows the minus 1 oxidation state. Oxygen shows minus 1 by 2 in superoxides. Its oxidation number minus 1 by 2 in superoxide. Its formula is O minus 1. So now one of the example is KO2. Then in this RbO2, CSO2. In this one compound it shows minus 1 by 2 oxidation state. For example, if you don't know, consider this is a X plus, already potassium known, therefore we can say this is a plus 1 plus this is 2x is equal to 0, because first rule what is the sum of the oxidation number of all atom is equal to 0. Then this can be written as 2x is equal to minus 1. Then from this x equal to minus 1 by 2. So this is a superoxide oxidation number minus 1 by 2. Similarly, we can write this is a O2 2 minus. Then this is, we can say 2x is equal to minus 2. Therefore, x is equal to minus 2 by 2. Then that equal to minus 1. Similarly, with this also we can calculate same O2 minus 1, meaning 2x is equal to minus 1, then x equal to minus 1 by 2. Oxygen shows minus 1 by 3 in ozonide. Its oxidation number minus 1 by 3 in ozonides. Its symbol is O3 minus 1. So like this it is given, mean O3 minus 1, that is 3x is equal to minus 1. Therefore from this x equal to minus 1 by 3. So in ozonides it shows minus 1 by 3 oxidation number. So here oxygen shows minus 2 oxidation state unless combined with the fluorine. That example I forgot, therefore I want to give here. This is OF2. In this, oxygen shows the positive oxidation state. For example, this is X, we don't know, consider, plus 2 fluorine. Already we know fluorine shows the minus 1 oxidation state in its compound is equal to 0, because sum of the all atom oxidation number is equal to 0. Then X equal to, this will goes right side, meaning there is a plus 2. Similarly, O2 F2. In this also this is a 2x plus 2 minus 1 is equal to 0. Then x is equal to 2 by 2, that equal to plus 1 oxidation state. So when fluorine combined mean positive oxidation state with other non-metals or anything compounds, metals also, then it shows the -2 oxidation state in its oxides. Seventh rule, for halogens, oxidation number -1 in most compound unless the other element include oxygen or more electronegative halogen. Generally, already halogens we know that X equal to fluorine, chlorine, bromine, iodine. Fluorine respect to already we studied, therefore we will not study this one now. We will discuss about this one. Now this chlorine shows the -1 oxidation state, bromine shows the -1 oxidation state, and iodide shows also -1 oxidation state. Example for this, NaCl, NaBr, NaI, like this some compound. Similarly, HCl, HBr, HI. In these compound, they shows -1 oxidation state. -1, -1, -1, -1, -1, -1 oxidation state. But another compound here statement they given, unless other elements include oxygen or more electronegative halogen. For example, for this statement is ClO2. This is one compound. Chlorine combined with the more electronegative oxygen. Then we don't know consider this chlorine then X, but already we know that oxygen shows in its compound -2, then that total equal to 0. Therefore X is equal to minus into minus, sorry, 2 into -2, -4 goes right side, +4. Then it shows +4 oxidation state. So when it combined with the more electronegative atom like oxygen and fluorine, it shows the positive oxidation state. For example, another one, Cl2O7. This is also one more example. Then this is a 2x plus 7 into -2 is equal to 0. Then 2x is equal to -14, and x equal, sorry, minus into goes right side, +14. Then 14 by 2, that equal to 7. So positive oxidation state +7. Similarly, it combined with the halogen atom ClF3. Then chlorine combined with the halogen, that is a fluorine. Then it is X. Then 3 into -1 is equal to 0. Then X equal to +3. Similarly, ClF7. Then this is X. Then 7 into -1 is equal to 0. Then X equal to +7 oxidation state. So halogen shows generally -1, but when they combine with the more electronegative element, they shows the positive oxidation state. So I given the each one rule which is exactly involved to find out the oxidation number of any compound very clearly with a very short and sweetest form explained. I hope you all of you understood this is very good with the a best example.